3D printing is the construction of a three-dimensional object from a CAD model or a digital 3D model. 3D printing can use different mixtures and materials, such as plastic, metal, wood, stone, to produce the desired product. In factory, 3D printing has brought several advantages that will be listed below. First, industrial 3D printing makes it possible to manufacture structures that are both lightweight and stable. Second, extremely complex geometries, organic surface structures, cavities and undercuts. With 3D printing technology, products can be completely reimagined, and a range of diverse structures can be integrated into the same part. Third, less material use, less energy consumption, so we have lightweight components. Lightweight designs are becoming increasingly attractive in a variety of industries, as less material use reduces costs per part, and lighter parts reduce weight. Therefore, energy consumption decreases. Fourth, production on demand, individual products or spare parts. Industrial 3D printing offers customization opportunities for needs-based production. Computer numerical control, CNC, machines could be considered a type of 3D printing. These machines are equipped with number control technology to accurately perform certain tasks, in particular cutting, shaping or machining of metals, wood, plastics and other materials. They have a computer installed with a GPS positioning system, but more accurate, that is thus able to control the movements, speed and other parameters of a cutting or machining tool, and thereby achieve customized finishes with a high level of precision. The CNC machine controls the position and speed of the motors that drive the three axes of the machine. Thanks to this, they can make movements that cannot be achieved manually, such as circles, diagonal lines and complex three-dimensional figures. Once programmed, it executes all operations on its own. These machines save time and money, resulting in cost savings due to less waste and minimized errors. When designing a piece, the software converts the dimensions into G-code language and the CNC machine makes the tools execute the program instructions immediately. In the video you can observe the software of a CNC machine with its code and a display screen, where you can follow in real time how it works. There are different types of CNCs: CNC lathes, CNC milling machines, CNC router, CNC plasma cutters, CNC 3D printers. Each of the types is discussed as follows. Lathes are perhaps the most widely used pieces of equipment with computer numerical control technology. They are machines that cut metal at high speed using rotary movements. CNC lathes are capable of making precision cuts and bores almost instantaneously, using solid tools and drills under the command of complicated algorithms, to produce parts that cannot normally be cut on manual lathes. These machines typically include 12 tool holders and coolant pumps to reduce tool wear. CNC lathes have similar control specifications and can read G-code as well as the manufacturer's own programming language. Milling machines, like lathes, are machines for cutting metal and other hard materials. In contrast, however, in milling machines, the workpiece remains stationary and the tool is machined by cutting or planing. The numerical control technology allows milling machines to have a wide range of functions such as face milling, shoulder milling, threading, drilling and turning. Here we can watch a video of a CNC milling machine. When the machine is prepared, the operator starts to run the program and initiate the CNC milling process with the machine. Based on the types of milling machine and milling parts application, CNC milling machines will rotate the milling cutters with up to thousands of RPM, to execute different operations, add the workpiece into the stationary rotating tool slowly, or move the tool across the stationary workpiece, or move both the tool and workpiece in relation to each other. On the CNC milling machines, a milling cutter can move along multiple axes and rotate in varying directions, which realizes various complex operations to produce diverse mill parts according to the CAD design. Routers are equipment that enable cutting and machining work to be carried out on a variety of large materials by dragging or routing to the cutting tools. The router is ideal for cutting materials such as sheet metal, wood, plastic, and even foam rubber and anime. A CNC router is ideal for producing profiles and sheets at impressive speeds, as well as machining materials in high relief. In this video, a CNC router performs decorative work on a wooden door. A CNC router is very similar in concept to the CNC milling machine, the type previously described. The human operator selects the machine tool, speed, cut depth and tool path. The operator determines the center point of the part, clamps the part onto the table, moves the bit directly above the marked center and down to the face of the part, and marks this as the starting point. The machine begins to cut the design. A plasma cutter has similar features and functions to a router, although it does not require the imposing size or configuration, as it does not pull or drag the material, but the plasma arc cutter, at very high temperatures, moves over the workpiece. It allows high-precision surfaces and finishes to be obtained on dense metals, acting by melting rather than cutting. Under the same mechanism, we can also have the CNC electric arc cutting machine. Here we can watch a video of a CNC plasma cutter type. CNC plasma cutters can cut through a wide range of different materials, including steel, aluminum, brass, and copper, and can be used for a selection of different industries like fabrication and welding shops, auto repair and restoration shops, industrial construction sites, and salvage operation sites. 3D printers operate under the functionality of numerical control. They can operate in different ways, on the one hand, by using additive manufacturing to produce parts or molds and, on the other hand, by directly cutting the material, CNC with wire or water cutting, giving it a specific shape. Each of the types is discussed below. Additive manufacturing refers to all techniques of manufacturing by the addition of material, i.e., material is deposited layer by layer in a controlled manner to produce designs. 3D printing could be limited to a specific type of additive technology. The technology applied for 3D printing can vary, so it can be done by laser sintering, UV curing, or the addition of a binder. Here we can watch a video of a CNC 3D printer. 3D printers are generally faster, cheaper and easier to use than other additive manufacturing technologies. 3D printers offer product developers the ability to print parts and assemblies made of different materials with different physical and mechanical properties, often with a simple assembly process. Advanced 3D printing technologies can even provide models that can serve as product prototypes. Another way of using CNC machines for 3D printing by additive manufacturing is the production of molds. This type also employs the deposition of layers of material, but the aim is to create a mold which is then filled with the selected mixture to produce the desired part. Here we can watch a video of a CNC 3D printer printing an injection mold. The majority of plastic products in the world today are manufactured by injection molding. With CNC 3D printers, temperature-resistant 3D printing materials, and injection molding machines, it is possible to create 3D printed injection molds in-house to produce functional prototypes and small, functional parts in production plastics. CNC machines for cutting material have a computer installed that controls the position and speed of the motors that drive the three axes of the machine. This type of CNC machine produces a three-dimensional molding. There are different types of CNC machines, with metal wire or diamond cutting and with water jet. The CNC with metal or diamond wire cutting cuts through the workpiece, cutting parts with different profiles. This method allows precise cuts of any thickness by means of a system of pulleys through which a wire with diamond beads or diamond wire circulates, which is the one that performs the cut. This allows it to cut a large amount of construction materials, including some metallic ones, concrete, reinforced concrete, pavement, asphalt, ceramic components, cement, granite, marble, slate, limestone, sandstone, glass, PVC or metals. In the case of the CNC with water jet, the materials are cut by impacting on it a jet of water at high speed that produces the desired finish. It is a revolutionary process that nowadays is extremely useful and is beginning to be a common resource when machining parts. It is quite simple but at the same time very complex. It is a very versatile tool whose application can be extended to practically all industrial jobs. As it is a cold cutting process, it is particularly interesting, as it is in demand in all applications where the material cannot be affected by heat. There are numerous advantages that make this product stand out in the industrial world, compared to other more limited methods. This technology can cut any material, metal, marble, plastic, etc. Here we can watch a video of a CNC with diamond wire for cutting the stone. This type of machine can produce delicate structures without deformation or micro cracks. The material is thermally removed by electrical discharge between the continuous wire electrode and the metal base. Here you can see some images of CNC cutting different materials such as plastic, wood, stone and metal. There are practically no examples of this methodology applied to the construction of artificial reefs, although it is very frequently used in the field of construction and design. We have included it in this presentation because the CTM have used a CNC for the Coral 3D project. This project aimed to build an artificial reef for Mediterranean corals using quarry residues. A limestone block, extracted from a quarry, which had been discarded by the industry for various reasons, unwanted size, imperfections, breakages, etc., was used. Artificial reefs, structures that are anchored offshore to support marine life, must have a certain complexity to allow the different species to settle on the surface, slopes, hollows, texture. To fulfill this task, a 3D prototype reef design was first designed using the limestone residue by digitizing it by industrial tomography. The design was hand transferred to a CNC machine that combined stone cutting with lathes, diamond wire and water jet. The CNC printed the 3D design by programming it. Here are some videos of the manufacturing process. The result was an artificial reef with different niches for both Mediterranean coral species and other species such as algae and fish.